All right, here you go. Remember your test corrections, just different color, so that I know that you're really doing them. Okay, so in your books, I'm just going to take a quick look real quickly. So you're doing same thing. You're doing numbers 1 and number 2, but the one-sided and absolute value functions, this piece, we still haven't gotten to. This has been the longest days of my life. 3.1 is taking us forever. So just disregard absolute and one-sided, which means piecewise functions. You can actually skip that part. Any questions that you get for that, okay? We won't get to that by the end, I don't think. So on Friday, you guys ended with just being able to make sign charts. You were able to make a sign chart for F. You were able to make a sign chart for F prime. You were able to approximate derivative values. So the word derivative meaning slope of the tangent line. Those are the things you were able to do. Today I'm actually going to show you real quickly how to sketch a graph of a derivative first. We'll start with that. I don't have an area for notes in your packet on this, I noticed. So if you want to kind of search through and see where you want to put it in your 3.1 notes, you may. The cover might work, or you can take out a sheet of paper. That works also. We're going to create a graph. Let's do... There's your graph. So I'll give you a second. So if you're wondering where you can put it, you can actually fit it on the cover if you'd like, or if you want to take out a sheet of paper and add it in there, that works too. You're just going to make one quick sketch of a derivative. You're going to have more practice on this later as we go, just kind of each day maybe doing 1 or 2, but I wanted you to see how everything from Friday connects. So to start off, I'm going to give you guys a second to copy that down. So draw some axes. It doesn't have to be perfect. You're going to make me a graph. Okay? So then, as I go through, I'm going to put some points on the graph. And then you are physically going to give me a, let's do positive is thumbs up, negative is thumbs down, 0 is a cross, undefined is a fist. Okay? So positive, put your thumbs up, positive. Physically put your thumbs up right now so I know that you understand all the symbols. Negative, 0, undefined. Okay, here we go. Oh, lordy, undefined is fist. No thumb out. Yep, no thumb out at all. All right. So when I do this, you're just going to give me a thumbs. Positive, negative, 0, undefined. So the answer is positive. Patrick, what are you doing? How do you have 3 fingers? I only define thumbs. What are 3 fingers mean? What? Oh my lord, someone help the boy out. All right. Ty, did you just give me spirit fingers? Good. Okay. So we know if our slope's going to be positive, negative, 0, undefined. So first thing I want you to do is draw yourself a sign chart for F prime. All the way across. I want you to fill it out. And then I'm just going to give you a quick way to sketch a derivative. We'll do more sketching as time goes on, but I want you to at least see it. It kind of connects everything together. So you, in your table groups, I would like for you to make your sign chart, double check that it matches the other people at your table groups. Please. This is the graph of F. Oh, sorry, I said F and then I wrote F prime. You don't have to label them underneath because I didn't scale it. The dolphin. All right, looks like you guys are all done. How many values were actually marked on the sign chart? Total of how many? Those. All right, one here, one here. What value went on top of those? Zeros. You physically will write the number 0 on top. Okay? Prior to the first 0, what sign should I put? Plus, minus? Plus. After? Minus. After? Okay. Real quickly though, if I put a point right here on the curve, how about the f of x value? The f of x value here is negative. The f primed value is, okay, don't get those confused. So here is your tangent line. Your tangent line is slope. The slope is positive, therefore the f prime has a plus sign, but the value of f of x is negative. Good. All right, so here's what we're going to do. We're going to graph the derivative. I'm going to sneeze. Let me try. So here's what you're going to do. I'm a little bit off there, but does everyone see that that would be where your horizontal tangent is? How much is the slope at that tangent? 0. So you're going to go to the same x value, and the new y value for your derivative would be 0. So does that point make sense? We kind of ended class with that. Same thing here. Here's your horizontal tangent. Does it make sense that your y value is 0 for that if I'm graphing the derivative? Okay. So, when graphing the derivative, I'm going to put it underneath. I'm going to write it a little bit differently. So when you graph the derivative, the plus sign that you had for f prime, how does that graph on here? Well, plus signs tell you that the curve was increasing. That was what we learned on Friday. A plus sign for the derivative now means that the graph of f prime is above x-axis. And then the minus sign, f prime, is below. Which should make sense, because all our zeros, we wrote them in as zeros. So your graphs will be a little different, but the general curve will be the same. So if I want to draw these plus signs, where should my pen be? Up here somewhere. I'm going to have to hit this. What happens between my two zeros? Where will my graph be for the derivative? Underneath. And then after, where will my graph be? Positive, which means above. So you're going to go underneath, come back up. Will your graph look exactly the same as mine? Probably not. That's okay, though. Shouldn't you be the one that knows that? All right. Therefore, let's see if it makes sense. I'm going to use highlights just to see if it makes sense. Where's my highlighter? There it is. All right. So, because this part of the graph increases, does that make sense with this part of the graph that is positive? So that yellow, so that should happen every time. So anytime my graph of blue, f of x, increases, then my graph of f prime should be positive. Does that make sense? Ty, we good? We good? Kind of. All right, and then let's see what happens. If the graph is decreasing on f of x, that means all my slopes are negative, which then means when I graph the derivative, my derivative values here have to be negative. Have I lost anyone? I hope not. It is so pretty. Okay? I told you it was going to start to get confusing because you start mixing the two types of graphs. All right. I just wanted to kind of show you that because that's where we're going with you guys finding just one slope here, one slope here, one slope there. Then I also made you do the sign chart. What we didn't do was completely draw the derivative. Okay? We have not done much of that. All right. Here we go. So I'm going to skip this warm-up for today. We'll do it probably tomorrow. We're going to talk about slope of the curve. You're going to notice that today's notes, it's kind of a review. It's as if we're reviewing last week's, or 2.4's notes. That's what it seems like. Okay? So, slope of a curve at a point. That is the same exact thing as instantaneous. Get my pen going. Instantaneous rate of change, which is the same exact thing as the new word you learned. What's the new word that you learned? Derivative. Okay? So, what does that mean? It means that f primed of a is equal to, and you'll see me use a's, because that's an a right here. Therefore, I use a's in my formula. If it was an x, then I use x's. Pretty much you can use either. Okay? Really? No one? Other than one? No one? Oh, true, yes. What's missing? Come on, people. Come on. The limit as h goes to 0, you have to have it. You need it for an instantaneous rate of change. Okay? Alright, so now that we have that, let's do that example. You already know how to do it. We've actually done this already. So it says find the slope of the curve at x equal to a. So what are they really asking you for? F primed of a. That's what they're asking for. F primed of a is how you read it. So, let's use blue. So f primed of a is equal to the limit as h goes to 0 of f of, and I'll use a's, all over h. So my question, why is there a minus sign in there? Is that random? Did I just decide I wanted a minus sign today? Yes, it's just a random. Where did the derivative formula come from? The average rate of change is where it came from. What is the average rate of change the same as? Slope. And what's in the middle of your slope formulas? Minus sign. Some of you are still using a plus. Okay? Minus sign, please, please, please. Alright, now that we have that, I'm going to try my best to squeeze my work here. I'm going to probably not squeeze. I'm going to leave that there, and then we're going to find f of a plus h, because I don't want to do this work inside of here. Okay? It causes you to make mistakes. So off to the side, we're going to do f of a plus h. So what do I do with all these nice little x's? Substitute in what? A plus h. Alright, negative parentheses a plus h squared plus 3 a plus h. So I'll go across. Please get good at squaring that term. If you don't know how to, you're going to physically have to do this each time, every single time. You're going to write it out twice and you're going to multiply them every single time. Alright. A squared plus 2ah plus h squared plus 3a plus 3h, and then I guess I'll just distribute my negative. That's not distributing. There we go. Minus 2ah minus h squared plus 3a plus 3h. Alright. Have I lost anyone yet? Hoping you ride this knowledge train all the way to the end and don't hop off, please, my lord. Don't let me lose you. Alright. So, I'm going to need that. I'm actually physically just going to copy it over so that you understand I'm literally just using it. Alright. Oopsie. Insert. That is totally out of order. That's going to bother me. There we go. Okay, so f primed of a would be equal to the limit as h goes to 0 of So the first thing I'm going to do, I'm literally going to copy over exactly what you guys just came up with here. That's this guy. When you do your minus, I'm going to do it in blue. Please don't forget this part. If you do, you'll end up with a wrong answer. It just won't work. The problem physically doesn't work out if you forget that. And what was the original function? F of a would be negative a squared plus 3a, I believe. Is that correct? All right. And then don't forget your h at the bottom. Anyone lost on where I magically came up with the blue part, the red part, the fraction, the limit? Okay. So, blue part, that's f of a. So negative x squared plus 3x was the original function. And then all I did was put an a instead of x's, because I didn't use x's here. Does that make sense? Okay. All right, distribute your negative so we don't forget about it. I'm going to turn that to a plus, turn that to a plus, turn this to a minus sign right there. So, negative a squared, positive 3a, negative 3a. You should be able to eliminate all terms without an h. Limit as h goes to 0 of negative 2ah minus h squared plus 3h all over h. I'm going to slow down and just make sure we do all of our simplifying steps correctly. What I mean by that, I'm going to factor out an h. Because you'll see it on your test. I put nasty notes to you because you do weird things like just simplify one of the h's out. It makes me angry. Okay? So you want to make sure you distribute completely, not distribute, factor out completely the h. Therefore, now they cancel. Why am I doing that? Because remember, you're taking a limit, and if we try to substitute, it won't work. So I got to make sure that when I substitute, it does work. All right. Now that I have that, does it make sense that we're just going to take this limit to 0? Now I can substitute that in, and my answer becomes negative. Oh, this pen is killing me. Negative 2a plus 3. Did I lose anyone? Are we all still on this train? Okay. So we got our answer. What's the actual question after that? Well, let's look. We end up with pretty much a bunch of the same similar type of questions you've got before in 2.4. Just making sure. F of x was negative x squared plus 3x. F prime of a was negative 2x plus 3. So what do we get? Go ahead and do B, C, and D. You should be able to go straight through. Find the slope of the curve at x equal to 2. Can you double check right now? Can you actually put the notation, please? F prime of 2. I don't want a random number just sitting in that spot. And what do you guys get? Negative 1. So you take your negative 2 times 2 plus 3 and gives you that negative 1. Find the equation of the tangent line in case you forget how to. Y minus y1 equals m times x minus x1. You'll start to see that your book may write this a little bit differently. Essentially, you're just using values that you already use. So you may see this. Oopsie. Times x minus a. Does that look quite different? I think it looks quite different. Does it say exactly the same thing? Yes. So if that confuses you, go back to point slope form, use it. I'm completely fine with that. All right, so what does that mean? Then your answer, well, I have my slope. I think I'm missing f of 2. F of 2 would be negative 4 plus 6. Hopefully you get positive 2, not negative 2. Not 10. I don't know. You get weird things sometimes. All right. Y minus 2 is equal to negative 1 times x minus 2. Therefore, what's the equation of the normal line? Y minus 2 is equal to positive 1 times x minus 2. Matthew, how do I get the slope that's sitting here in my normal line? What kind of reciprocal? Just a reciprocal. The reciprocal of negative 1 is negative 1. The what? Negative reciprocal. Beautiful. Thank you. All right. So, now that we have that, I gave you guys this guy, which just reiterates, summarizes all of that we just did a second ago, which you did in 2.4. That's why I love this section. The derivative of a function f with respect to the variable x is the function f prime, whose value at x is. So, f prime of x, I'm just making you write it 30 million times over and over and over and over again, so that you don't forget it. I proved it to you, and yet some of you still don't use the minus signs. Proved from slope. Alright, which is also known as, and we've written this 30 million times. Why? Because I want you to remember it. Instantaneous rate of change. Slope of the tangent line. But it's nice to be able to just say the word derivative. It's a nice way to say it. Then you got another problem underneath there. I'm going to skip that for now just to make sure I get to the end. If we can come back to it, I definitely will. This guy. It's just another example. I tried to do a different one where I had a fraction instead. That's all. This I need to get to because it's the part that I told period 2 they had to watch the video for. Period 4, that's right. I don't know why I said 2. I don't know. Alright, derivative at a point. Some teachers use this as the one that everyone uses. I use the limit as limit as h goes to 0. I like that one. I prefer that one. You can use either one. So here's another one. Same exact thing. So literally, it's going to look just like the slope formula. Because it is. It's a slope between a point x and a point A. It is physically the slope formula. There's nothing different about it. The way that you use it, it changes the way it simplifies, okay? I always do this last. I didn't leave myself enough space. So everyone saw where it came from? So I'm going to add in the part that we need. So you have a point X, you have a point A. This is an average rate of change. How do I make it an instantaneous rate of change? I take my A, let's do it this way. Take my X and move it towards A. There's where the limit comes from. And I'm going to do that in red as X approaches A. X is here, A is here. You want the distance between them to get smaller. We used to call the distance H. Well, now it just says, never mind, just move the point X closer to where A is. That's all it says. So yes, you still need a limit in there. Okay? Now that you have it, we're just going to use that the two different ways. So, on the left side, we're going to do it the way we're used to. On the right side, we're going to do it using the new definition. Either definition is acceptable, okay? So, this, the reason why I had you skip it, because I knew it was showing back up again, limit as h goes to 0 of f of, I'm going to use x plus h then. There's f of x plus h. We're going to need it, right? Minus what goes over here. The second part. Negative 3 over x, good. All over h. I'm going to try my best to stay in this box. Okay, are we okay with this? Turn that positive, get rid of the double negative. Alright, multiply this guy by x over x, multiply this by x plus h over x plus h. Try to get this pen to work. Okay, and what do we get? Negative 3x on top. Plus, thank you. 3h, whew, all over, common denominator, you see it, x times x plus h. I'm supposed to divide by h, what can I do instead? Multiply by 1 over h. Is anyone confused on what I did there? Okay, I don't want a stacked fraction, that's all. So, negative 3x, positive 3x, they're going to cancel. I'll write in the step just so we have it. I get 3h over x times x plus h times h. H's cancel. I'm going to actually put in the limit now. What should the h go towards? And what do we get as our answer? 3 over x squared. So if we do it correctly, we should get the same answer on the right side. Okay, I'm just trying to show you two different methods. Either one works for me. I don't care which one you use. So this one, the limit as x goes to a. Notice that that one has h's. This one has x's and a's. Please be careful. So this one we're going to need f of x. And just in case, since the first time you're seeing it, I'm going to write the formula back up again. Okay, that's what we're using. F of x, negative 3 over x. F of a, negative with a minus sign, will give me this. All over x minus a. We good? Have I lost anyone? We're good on where everything magically just came from? Okay, so now we just simplify. Similar type of simplifying, common denominator. So multiply this by a over a. Oopsie, wrong color. Picky about that. A over a. Multiply this by x over x. Anyone lost? Confused? So there was a minus and a negative, so I turned it into a plus at the time. I'm sorry. Okay? Limit as x goes to a, numerator, I get negative 3a, positive 3x, all over a times x, multiply by 1 over x minus a. Are we good? I moved my denominator one more time out of the way. Baldrick, what you doing over there, buddy? Huh? We're just taking it all in visually. Okay. Well, so did Jasmine. Jasmine, give him a hint on what you're doing. Help him out before I rip him apart. All right. So this can be simplified a lot more. Someone give me a step, something to do. Something that will help, hopefully. Right. I can. Very true. What would you like me to do to make this process a little easier and other people to be able to tell what you're mentally doing? Just skipping some steps. Help us out. Okay, so you combine this together just... Okay, so I'm just going to go like this. Okay. Okay. Ah, I see. You got it. All beautiful. Perfect. Love it. We'll summarize it slightly differently. Okay? I'm going to factor out a 3. Same thing, right? We're good? Okay. I'm going to factor out a 3. But when I do that, does everyone understand the a will be negative, the x will be positive? So all I'm going to do is write it the other way so it makes sense. Okay? I have a way of explaining things very well, I know. Same thing you were saying. Right. It's exactly the same thing. Is anyone confused, or does anyone think I changed the problem at all? Does anyone have an argument against what I did? Because when you factor, it should always make sense. 3 times x gives me the 3x. 3 times negative a gives me the negative 3a. So I didn't change the problem. I made it look different. I want it to look different, so I can do this. Why did I want that to happen? Because when you do x goes to a at the very beginning, what do you get at the bottom? A minus a, which makes 0, which makes a limit of undefined. Bad things, bad things. So, what do we get? I'm going to go down here just to save a little space. Limit as x goes to a of 3 over ax, but the x, just kidding, the x is going to what value? So make sure the x is the one going to a, and you get 3 over a squared. Is that the same thing as what I had before? Yes. If you do it right, they should be the exact same answer. Both methods work. I teach this one because I see it show up more often on the AP test. That's why I use this one more. This one works just the same. You're allowed to use either. I want you to get good at both. So then the next one, other notations for derivative, I think that's somewhere. And I think I gave you guys that last week. I gave you f prime of x. I gave you dy over dx, both of those. So that's f prime, means first derivative. This one means the derivative of y with respect to x. It's just two other notations that you'll see us use. And then, did I skip something? Yeah, there was one more of these, right? Okay, it was the root of x, I hope? Okay, sorry about that. No, I definitely didn't. I was wondering where that page went. That's where I actually want you to end class. You should be able to do this guy both ways. Limit as h goes to 0 of, I'm not going to write the formula. Actually, I will write the formula. You guys don't have to. Summarize what we did. So there's that guy, and there's this one. Remember I said I would give you definitions quiz? I said I would put on what? I think 2 more definitions of the derivative. That's these guys. These are the definitions I said I would squeeze on there. So you should be able to do each of them. I'll start it for you. Over there. And then this one. The work you do, pretty much the same though. You still do very similar simplifying process. Alright, that's where we're going to end class. You guys should be able to complete that process of simplifying to get down to the same 2 answers. Completely the same when you're all said and done. I'll at least give you the answer so you know if you're right or not. That's what you're trying to end with. Don't you dare just write it down. I want you to get there.